Hello and welcome everyone. Our today's question is largest BST. So we have given a binary tree and we have to find the largest subtree which is a BST. So we have given this tree. In this tree we don't have any subtree which is BST. So we can take a single node. So its size is 1. Go to next example. We have this tree and in this tree we have one subtree which is a BST. So this subtree 1, 2 and 3. So 2's left is smaller and 2's right is greater. So every node on the left hand side of the current node is smaller and every node on the right hand side of current node is greater. So its size is 3. So let's build the approach. I am taking this test case. So in this, we have to find the largest BST size. So we know what is a BST. We have given a current node and its left side node and its right side node. Maybe its right side is null or maybe its left side is null. So all the values on the left hand side must be smaller and on the all the values on the right hand side must be greater. So we are familiar with this. So we can write it like this. Left values must be smaller than current value and right hand side all values must be greater. So left hand side we have a subtree and we want to find the value that is the closest of the current value. So the closest of the current value, suppose we have a tree here and there are so many nodes here. So we want to find the largest node. So the largest node must be smaller than this. So we will find maximum value from here and we will find minimum value from here. So we have many nodes here and every value must be greater than the current value. Why I am emphasizing on the minimum value? Because all the values must be greater this current value and this minimum value must be greater, must also be greater. So this is the maximum value and on all the values on the left hand side must be smaller. So we will find maximum from here and minimum from here. So there is no way we can say that maximum value we can find from here. So we have to find minimum and maximum from both sides, minimum and maximum from both sides, but we are only interested in the maximum value here and minimum value here. But we also need the size of the subtree. So one more thing we have to pass, which is size. That's all. So let's build this. First we go to left hand side, then we go to left hand side. So this is null. So we have to return in such a way that this node must be true. So we have to return the node in such a way. So its left side we have to return in such a way that we have null here and null value then 6. So it's left 6 left. So 6 left we have to find and we have to know the minimum value. So it must be smaller, but null value we have to return in such a way. So we will return integer minimum minus infinity, infinity and 0. So we can say its maximum value, left maximum value must be smaller, but in this case it is not. So we have to swap the values. So we have to return this way, plus infinity, minus infinity, then 0. Then go to its left hand side, 2. Then 2's left, 2's right. So 2's left and 2's right is null. Null, 2, null. But this subtree is a valid subtree and it is a BST. Single node is also a BST. So we have to return infinity, minus infinity, and 0. So infinity, minus infinity, and 0. For null value, we will return this array. So we have to find this maximum value. I am storing minimum on 0 position, maximum on 1 position, and size on the second position. So we are only interested in this or this value. Just check. Is the range valid? Minus infinity, then 2, then infinity. Yes, it is valid. So that's why we have to return the array in infinity, minus infinity, and 0 this way. So this will make this subtree valid. So now it's time to return the array from 2. So how we will return array from 2? So right side we have to return from this. So return from here. So we will build array. We are at 2 and we have to build an array. As you can see, its left and right is not, left and right is null. So the node itself is its current node, minimum node, maximum node, and size is 1. And we have a global variable answer from which we are storing our answer. So we will return, we have 2, 2 and 1, and we are at 6. So just check, minus infinity, then 6, then this value 2. No, this subtree is not valid. So we don't care about the upper tree because this subtree only itself is not valid. So we can return anything. So we will return the worst values. What do you mean by worst values? So we will build an array, and for null we are returning like this, plus infinity, minus infinity, and 0. So in this case, if the tree is not valid, so we will return this. So this will make upper tree also not valid because its subtree is also not valid. This current tree is also not valid. So we will return from this, and we have left array minus infinity, then infinity, then 2, 0. So this will make the whole tree not valid. But we have to go to right side first. So go to right side, we are at here, then go to left side, we are at here. Let's erase some values first. If you don't understand now, so I have one another test case, just bear with me. We are at here, then we are at here. So it's left tree, it is. So we have to return for null, we have to return infinity, minus infinity, then 0. So for 1 we are have null, then null, then null. So its value is infinity, minus infinity, then 0, infinity, minus infinity, then 0. So this value and this value, so minus infinity, 1, and this. So it is valid. So we will return 1, 1, then 0. Oh, sorry, 1, because left hand side size, subtree size is 1. So for tree, for 3. For 3 we will also return 3, 3 and its size is 1. Now we are at 2. So 2's left we know, 2's right we know. So we are only interested in the maximum of left hand side. So the maximum of left hand side is this. So it is 1. Then 2 is the current node. Then we are only interested in minimum of right side. So it is 3. So this subtree is also valid. So we have answer 3 because left hand side size is 1, right hand side size is 1 and 1 for this current node. So we have 3 answer. So as I said, we have global variable answer in which we are storing our answer. So our answer is 3 now. Now we have to build our array. We know we are we have to return minimum, maximum and size. So minimum is present on the left hand side. So we will add our left 0 and maximum is present on the right hand side. So we will pass right of 1 and size. Size is the left 2, right 2 plus 1. So we know the size. So we will return this. So we will pass our array from this. So we have a right array as left 0, 1, 3 and 3. Because on the right hand side as you can see the minimum value is 1, the maximum value is 3 and its size is 3 also. So let's check for the root node itself. So we are only interested in the maximum, it is infinity. Then we have 6, then we have 1. So it is not valid. So we will return minus infinity, then infinity, then size. We don't need size because the subtree is itself not valid. So we can pass the size anything. You can pass the size anything, minus infinity, minus 1. So here I am passing minus 1. So that's it, we have our answer 3. Now check for this test case. Will it work for this test case? Let's check it. So we have root node itself. So first we have to go left hand side, then from here we have left hand side, from here we have left hand side, from here we have left hand side. So we have null. So as I said, for null we have to pass minimum, maximum, then size. So for minimum, for null node to be valid, we have to pass infinity, minus infinity and size 0. So for 3, 3's left is this, then we have 3, 3's right is this, and we are only interested in the maximum and minimum. So this node, then this node, then this value, then this value. So this make our subtree valid. So we have to return this value, then this value. Oh, this is a node itself and its left and right is null. So from 3 we have to return 3, 3 and 1 because for the current node 3 is itself minimum, 3 is itself maximum and its size is 1. So we will return this. So we have our left tree 3, 3 and 1. For right tree is null. So we have infinity, minus infinity and 1. So let's also maintain a global variable answer. Answer is 1 now because for 3 we have left and right subtree valid and we then we take size this size and plus 1 for node itself. So that's why we have our answer 1. Check for 5. Check for 5. For 5 we have 3, 3, then 1, then 5 node, then infinity, minus infinity, and 1. So this is a crucial point. If you understand this point, then you are good to go. We have this minimum, this maximum, this minimum, and this maximum. So we are interested in the maximum value from here, from left hand side, and minimum value from right hand side. So this is a valid subtree. So 3, then 5, then infinity. So we will take size 1, 1, and 5. Oh, sorry, right subtree is null. So null size is 0 here. Okay. So we have our answer 2. Then what we pass from this node? We will pass 3. Yes, but we cannot pass we cannot pass minus infinity, because the maximum value till now, we have is 5. So we will pass 5, and size is 2. So just check if the right is null. Null means if the right side we have minus infinity, or the root itself, the root right node is null. If the root right node is null, means till current node we have maximum value, the current node itself. So we will pass the maximum value as the current value. Same goes for left hand side. If left hand side is null, suppose we have this tree, so this subtree is also valid. So from 4 we have to build an array, and its minimum value is root itself, because its left hand side is null. And if the left hand side is null, so we will update our left of 0 to the node itself. So we have to pass 4, 5, and 2, this. So that's all. Let's code this. I hope you got the idea. So we have answer variable and minimum value, maximum value, then answer, then solve function, and we have to return our answer. So let's build the solve function. For the root node, first we have to pass array of 0, array of 1, and array of 2. On array of 0 we have to maintain minimum value. On array of 1 we have to maintain maximum value. For the null node to be valid, we are passing maximum to minimum and minimum to maximum. So then we have to go left hand side, then right hand side. So just check, is this the node valid? Is the current node valid or not valid? So first taking the size, then array, then check, is the tree invalid? Invalid means the left hand side maximum, the maximum value from left hand side must be smaller, or if it is greater, then this is not a valid subtree. Or the minimum value, and the minimum value from right hand side must be greater. If it is smaller, then this is not a valid subtree. So just pass anything. I am passing, so we are maintaining minimum, so I am passing minimum, then maximum, and size -1. You can also pass size minimum. This will not affect our result, else our tree is valid. So if our tree is valid, then just check, you can pass the check afterwards. So I am checking here. So if left and right is not null, means this is the leaf node. So for leaf node we have to maintain, we have to return an array, this array. So for this we have to find the left hand side. Left hand side means minimum, maximum, and size. So for minimum I am passing values here. Then same goes for if left null, then this is the left null means this is the minimum node. So I'm passing minimum, I'm passing minimum. And if the right hand side is null, so this is the maximum value, so write 1. So then I am building my array. So this is my array, and the size we already know, this is our size. So if this is valid, then this case, and we also have to update our answer value. So if the tree is valid, then update our answer value. So answer we have updated. So then return our ARR, which we have built for the current node. So that's it. So here I am updating my left 0 because left 0 contains the minimum value. So here I am updating my minimum value, and right one maintaining the maximum value. So I am updating my maximum value and putting the value on the answer array. So that's it. We have submitted our code. So a click on the subscribe button is highly appreciated. If you have any doubts, feel free to ask in the comment section. Thank you all for watching this video.